Okay, so when we're talking about infinite limits, what we're talking about is when a function either increases or decreases without bound, which we have already discussed this before, and we've always just said it does not exist. The limit does not exist, which is still true. The only difference today is we are saying that it either goes to infinity or negative infinity, and that is the reason why it does not exist. So it's just kind of an explanation. It's one step further than just saying it doesn't exist. So in this first example, they wanted me to evaluate first by using a table and then by a graph. So first, if I use a table, I need to think of this as a function, so y equals or f of x equals, not just a limit. And then I need to take these values, plug them in for x, and find out what this f of x value is, or y. So when I did that, I got these values. And if you want to check that, plug those in for x and make sure you get the same thing. And what it looks like to me is these numbers keep getting to be larger and larger negative values, so smaller and smaller numbers, which to me means that's going to negative infinity. But on this side, as I get closer and closer to 2, it's getting bigger and bigger values, which makes me think it's going to positive infinity. Okay, so then when I look at it graphically, I do see that that is what's happening. So I have this asymptote right here at 2, which is giving me this does not exist limit. So back up here, if I were to have taken this and just plugged it straight in, direct substitution, I would have gotten 3 over 0. So if you get a numerical value over 0, that's when you know a vertical asymptote has happened. So we'll talk about that again in a minute. Okay, so this is all they wanted me to do though. They wanted me to get a table and a graph and then move on. Okay, so then the second one, they're wanting me to take this and tell them what that limit is. So just from the left side and from the right side of 2. So I'm going to use a graphing calculator for this. So when you use the graphing calculators that we have at school, we need to start by using this on button, this home button. And typically what you'll do, let me go back to the home screen. You will say, yes, I want a new document. So you will either just hit this middle cursor right here because it's highlighted on what you want, or there's a 1 beside that because you can also hit the 1 on the keypad and that will get you the same result. So I'm just going to hit that middle key. No, I do not want to save it. I don't ever save anything on here, but you can if you want to keep it for later. And then I'm going to add a graph. So again, I'm going to either go down to highlight it and then hit the middle, or I'm going to hit the number 2 on the keypad. So I'm going to add a graph, and then I have to type in my function. So my function in this case was y equals the tangent of pi x over 4. So in this case, it already has my f of x equals, and I'm going to type in tangent. Now in order to do that, I have to hit my trig values right there next to the 7. And when you look at the screen, this is what it does. So I have to arrow over to tangent, click that. And that puts my tangent function in there, but now I need to get pi x over 4. So down here, and far down at the bottom towards like your letter keypad, there's a pi button, and that gives you all of these values. So I'm going to hit pi, and then I need to put my x in there, which again is down here on the keypad. So now I've got pi x. And then over, I'm just going to use my division button for over 4. And then close my parentheses up, and I'm going to hit enter. And that's going to graph it for me. So now my job is to look at what is happening as x approaches 2 from the left and from the right. So if I look right here at x approaching 2, from the left, it's going up to infinity. And from the right, it's going down to negative infinity. So that's my answer on these. I'm just going to do from infinity on that one, negative infinity on that one. Oh, I'm clicking on stuff here. Okay, so those are my answers for that, and I don't have to do anything else. So this is kind of the easy way out on this lesson. That graphing utility is really helpful. Okay, so then we get into these types of examples here. So this is asking me to find vertical asymptotes. So vertical asymptotes, like I said earlier, If I were to get a numerical value on top but 0 on the bottom, that's a vertical asymptote. So I'm going to start by just saying, well, when will that denominator be 0? So when will x minus 2 equal 0? Well, that happens when x is 2. And you can probably just look at that yourself. You don't have to write this out. I'm just showing you what I'm doing. But I want to know what happens to the function at that value. So what happens on the top and what happens on the bottom. So in this case, that's going to be 4 times 2 over 2 minus 2, which is 8 over 0. So again, I get a numerical value over 0. Well, that tells me that I have a vertical asymptote at x equals 2. That's where that happened. So there's my answer. Okay, so then the second one, so I'm going to try it too. So when x squared minus 1 equals 0, I want to know what's happening there. Well, that means x squared equals 1, which means x equals either plus or minus 1. So I have 2 that I have to check this time. So I'm going to check my function at 1 and my function at negative 1. So if I put a 1 in here, 5 times 1 squared is 5. And then 1 squared minus 1 is 0. I knew that was going to happen. So there's an asymptote at 1. And then this one, if I plug in negative 1, same thing's going to happen, because if I do negative 1 squared, I get positive 1 times 5 is 5. And then, let me get rid of that mark. The denominator is going to be 0. So there are vertical asymptotes at x equals positive and negative 1. So I'm going to write them both in there in this at the same time. You could have written them separately. Okay, now this one is one where I would just have to graph it and see what's happening. So I'm going to go back to this graphing utility again, go back to my main screen, new document. No, I don't want to save. I'm going to add a graph. And this is how I'm going to add it. So I'm going to type in my tangent again of pi x over 2. Enter that, and that's what I'm getting. So it's looking to me like there's an asymptote at 1 and 3 and 5, and then back here there's at negative 1, negative 3, negative 5. So every odd number, every odd value of x gives me an asymptote. So here's how you can write that. I don't know if you guys remember back. This is probably more of an algebra 2 thing. So there's a vertical asymptote every time x is an odd number. So I'm going to write that as 2n. So anytime I take 2 times some value, I'm always going to get an even number. So if I add 1 to that, I will always get an odd number. So 2n plus 1 always represents an odd number. If it was all even values of x, I would just put 2n. Now I do have to tell them that n can be an integer. So it can be positive or negative numbers. That's important to point out. Okay, now this last one, this one is a little bit different, because if I factor, so I can factor this out, x plus 3, x minus 2 would give me that one. The denominator would be x plus 3, x plus 1. And if I do that, this cancels. And that's important to know, because that gives me an x minus 2 over x plus 1. Now, I also know that x still can't be negative 3, because if it were negative 3, this would have been 0, right, at the very beginning. You always have to pay attention to that beginning. But if that were negative 3, the top and the bottom both would be 0. So in that case, that's a removable discontinuity. So there's a hole in the graph, not an asymptote. Asymptotes are non-removable discontinuities. So in this case, I don't care so much about this x equals negative 3. I only care about this situation, because if I plugged in negative 1, then the numerator would not be 0. So I would get a numerical value over 0, which is an asymptote. So this one has a vertical asymptote at x equals -1 only. Okay. Okay, so then these last 4. So I'm going to look at these in a couple of different ways. So actually, I'm really just going to look at it in one way. If I took this and I plugged it straight in, I'm going to end up with a 0 in this denominator. So really, the easiest thing to do when you get these weird functions like this is to graph them. So I'm going to show you how I'm graphing them. And I just put them on Desmos real quick so that you didn't have to wait on me to do this, to type them in. Okay, so this first one is this function. And if you look at it, they're asking what happens as the limit as x approaches 0 is the question. Well, that one very clearly goes to infinity. So I just have to go here and say, okay, well, this is infinity, and I'm done. The next one, this one is saying what's happening as the limit approaches 0 from the right. So I'm going to go back over here. I already typed this one in. Where is it? Right there. And they want to know just what's happening as x approaches 0 from the right. So if you look at this one, there's something weird happening right here. And up here, there's an asymptote right there. But they're asking about 0. As I get closer and closer to 0 from the right, what's happening? Well, it looks to me like it's going to 0. So this is one of those weird situations where there is an asymptote, but that's not what they're asking me about. They're asking me about that situation. Okay, and then the next one, this one, it's another one of those tangent functions, and that's this one right here. And they're asking me what's happening as x approaches 3/2 from the left. So 3/2 is the same thing as 1.5. So I'm looking at, let's see, here's 1.5. I'm looking right here. And they want to know what's happening from the left. So from the left-hand side, as I get closer and closer to this 1.5 mark, it's going to infinity. Okay, and then my last one, so this one right here, they want to know what's happening as x approaches 1. So as x approaches 1, so here's that function. I typed it into Desmos. As x approaches 1, which is right here, both sides are going to negative infinity. So since they're going to the same direction there, same place, I can say that this is negative infinity. If they were going to 2 different places, one going to infinity, one going to negative infinity, then I could say it just doesn't exist and not specify that it's going to infinity or negative infinity. Okay, so that's all for this lesson. I'll post the assignment.